In this section, we're going to define what we mean by average rate of change. And to put this in words, the average rate of change is going to be obtained by dividing the change in the output by the change in the input. Writing this down as an equation, we can do this as follows. This is going to be change in output divided by change in input. Now, if we want to go ahead and write this further, let's go ahead and have a picture. Given here, we have some function represented by the following graph, and we have two input values, call this x1, x2. The corresponding output values are given by f of x1 and f of x2. In this example, we're given this interval here, and we're giving these two y values here. The rate of change in this quick little picture here is going to be the change in y values divided by the change in x values. And this is given by f of x2 is equal to, that should be minus f of x1 divided by x2 minus x1. Writing this in slightly different notation, this is given by y2 minus y1 divided by x2 minus x1. And we can also write this as the change in y divided by the change in x. Let's go ahead and summarize this. If we want to write the rate of change in terms of an algebraic equation, this is going to be given by the change in y divided by the change in x, which is defined to be f of x2 minus f of x1 divided by x2 minus x1. If we wanted to write this out in words, we would say the following. The average rate of change given input values is the total change of the function values divided by the change in the input values. After writing that entire paragraph down, it's clear to see why we prefer mathematical notation. Example 1. Find the rate of change for f of x is equal to 2x squared plus 1 on the given interval 3 to 3 plus h. In this case, there's 3 steps. In the first step, we need to find delta y. In the second step, we'll find delta x. And in the third step, we'll divide delta y by delta x. In this case, let's go ahead and start with our delta x here. So delta x is going to be x2 minus x1. In this case, it's given by the right-hand side of our interval, which is going to be 3 plus h, minus the left-hand input of our interval, which is given by 3. And so delta x is given by h. Delta y in this case is going to be f of x2 minus f of x1. This is going to be equal to 2 of 3 plus h squared plus 1 minus a 2 times 3 squared plus 1. All of this multiplied by a negative 1. So let's go ahead and take this equation over here and simplify it on the next page. Okay. So this is going to become 2 times 9 plus 6h plus h squared plus 1 minus 18 plus 1. Oh, sorry, that should be minus 1. Distributing out the 2 in this first part, we're going to get 18 plus 6h. Sorry, I made a mistake here. This should be 12h plus 2h squared plus 1 minus 18 minus 1. We have this negative 18 here, this positive 18 here, so those terms are going to cancel out. We have this positive 1 here, this negative 1 here, those terms cancel out. And the only thing we're left with is that this is going to be equal to a 12h plus 2h squared. So taking our solution back to the last page, we'll now see that our y2 minus y1 divided by x2 minus x1 is going to be equal to the following. We're going to have our 12h plus 2h squared on top divided by our h, which is going to simplify to be 12 plus 2h. And this is going to be our solution. All right, in the next example, we'll go ahead and compute the average rate of change given some graph. So let me go ahead and draw this graph, and then we'll start. Okay, so here's our graph, and we're given 2 points on the graph here, the point 1, 1 and the point negative 1, 3. There's 3 steps, again, to finding the average rate of change in this problem. Number 1, we need to find the change in x. Then we'll find the change in y. The last part, we'll find the change in y divided by the change in x. In this case, we have x2 minus x1. x2 in this case is given by 2. x1 is given by negative 1, which means that this is going to be equal to 3. Our change in y is going to be given by our f of 2 minus our f of negative 1. And I just noticed real fast that I made a mistake. This point isn't 1, 1, it's the point 2, 1. Which means that f of 2 is going to be equal to 1 minus our f evaluated at negative 1, which is going to be given by 3. This leaves us with this being a negative 2. The average rate of change then is going to be given by negative 2 divided by 3. Let's compute one more rate of change algebraically. Find the average rate of change. For the function y is equal to 2x squared minus 9 on the interval between 4 and b. Again, our solution is going to come down to 3 steps. Find the change in x, find the change in y, and then divide those two values together. So the change in x, again, is x2 minus x1, which we end up getting a b minus 4. Our change in y is going to be given by f evaluated at b minus our f evaluated at 4. This is going to be 2b squared minus 9 minus our 2 times 4 squared minus 9. Simplifying this, let's go ahead and simplify what's in the parentheses real fast. So inside the parentheses, we're going to get 4 squared is 16 times 2 is 32 minus 9. So we get our 32 minus 9 here. And nothing happens on the left-hand side. We're still left with our 2b squared minus 9. And we see that this term is going to simplify out to be 2b squared minus 32. Let's compute the rate of change on the next page. We have our change in y divided by our change in x. Our change in y is given by 2b squared minus 32, and our change in x is given by a b minus 4. Simplify the top out, we can remove a 2, so this becomes 2b squared minus 16 divided by b minus 4. And this is going to be equal to 2 times a b minus 4 times a b plus 4, all divided by b minus 4. Canceling out our b minus 4s, we get to 2 times b plus 4. And this is going to be the simplified version of our rate of change.